Welcome to our standard where we're going to learn about graphing and developing circle equations. So I've got this graphic not in your book, but just to talk about some of the stuff about circles. So our circumference goes all the way around. Circumference is 2 pi r over pi d. Diameter goes all the way across, which is the same as 2 radius. A tangent touches the line on the outside at one edge of the circle at one spot. A secant goes all the way through it, so a line, and a chord endpoints are on the circle itself. So this is the equation of the circle. So you're going to have three things that are squared in the circle, in the equation. You're going to have an x term, a y term, and then a number on the other side of the equal sign. So I'm going to go to a little thing I have here on Desmos, and we'll see what happens when I change h, k, and r. So here I have x, there's a 0 and a 0 for h and k, and r is 1. And I can see a circle at the origin, 0, 0, which has a radius of 1. Then I go to this one, and I've only changed this to a 4. But the radius is, in fact, 2. And then I can go to this one. Now it's a 9, radius is 3. So this number, radius is the square root of this number. So square root of 1, 1. Square root of 4, 2. Square root of 9, 3. Then I can go and I can start moving numbers around. So let me get rid of these two. We have a radius of 1 because that's the number here. Square root of 1 is 1. I'm going to highlight this one. And I'm going to see that my circle is at 1, 2. Positive 1, positive 2. And the number here is minus, minus. So I'm only looking at the number itself here if it's negative. So it's like the opposite of the number. Then if I look at this one where it's still 1, but it's a plus 1 plus 2, well, it's going to be the opposite of that number. So it's going to be at negative 1, negative 2. So to recap, the number r squared, go back, r squared, if you see a number, it's going to be their square root. The h is the amount. It goes in the x direction, which would be left and right, and it's going to move the opposite of the sign. And then the k is the y number up and down, and both of h and k would be your coordinates for your center. So let's jump into this a little. Okay, so I want an equation with a circle, the center at the origin. So origin would be x, and I'm just going to put squared. I don't need to put the minus 0 plus 0 thing. Plus y squared equals 8 squared. So r goes in. Origin is 0, 0. It goes in. Next one, a center at 3, negative 5. So I'm going to start with this equation. X minus 3, because it's going to be the opposite, plus y plus 5, because it's the opposite. Both of those squared equals 6 squared, radius is squared. If you wanted to write this is the same as 64, or this is the same as 36, we would actually square that out. No problem, you can do that. Okay, so I'm going to look at some circles here now and actually find out the equations. So I first need to determine my center. Here's my center. The value is at negative 5, 0. And then I need to know my radius. So if at negative 5, I can count 1, 2, 3, 4, 5. Radius is 5. So I'm going to have x plus 5, it's the opposite, squared, plus y squared equals 5 squared. The reason y is by itself is because there's a 0. So why don't you pause the video and you try this one yourself. Welcome back. So I need to determine the center of the circle. So this is going to be my 0 in the x direction, and then minus 2 in my y direction. So then I put x, no number, and y plus 2. They're both squared. and I gotta find the radius, so I can just count over, or I could count up, and I would get that it's 6, so it's 6 squared. Okay, so this problem is not in your book, but it's we're gonna solve it a similar way. Consider the circle center on the origin with a diameter of 6 units. Okay, that means the radius is 8. I want to know if the point 7, 4 is on it. So 7, 4, that it looks like it is, but I don't want to just look, especially since I have to explain my reason. I want to make an equation. Well, it's 0, 0. So I'm going to do x squared plus y squared equals 8 squared. And my point, this is my x and my y. So I'm going to put in 7 squared plus 4 squared equals 8 squared. And if this is true, then the point is. And if it's false, then the point is not. So 7 squared is 49. 4 squared is 16. And if I add those together, I get 65. But 8 squared is 64. So while these two are incredibly close, the exact point 7, 4 is not on the circle. And I would explain, I made the equation, and I put in the x, y, and I got the answer. Oop, too far. Okay, so this is probably the hardest thing about the lesson is sometimes you have to complete the square. And this is a process you should have learned in algebra. And if you already know it, great, this is going to be really simple. If you don't know it, then this is now your chance to learn it. So if I have my equation of my circle, and I can do expanding it, which if I have x minus h, and what I like to do is this box method. So I have x squared minus xh, just multiplying down, multiplying across, minus xh, and then I have h squared. So if I add these together, I get x squared minus 2xh, and this is the cool thing about the box method. Diagonal will be the same term, and then plus h squared. Hey, look, that's what here is. So if I did the same thing with y minus k, I'd get this thing. And then what they'll do is they'll put all the terms in in ascending or descending order. Squareds first, and then x terms with a variable, and then just h and k terms. So I get this equation. The equation for a circle in general form is ax squared plus cyx plus dx plus ey plus f equals 0. So these are all numbers. Radius is a number, that's a number, that's a number. I can actually bring everything over to this side and make it as one number of f. So, yeah, so this is the equation. So how do I complete this square? Well, completing the square is when I have an equation in the general form, standard form, where I need to make it look like this, where I have x minus a number squared. And to get there first, I have to get it into this form, where I have x squared minus 2 number x and then a number. So to do that, we're going to complete this square. So I have this equation. First, I'm going to get my x's and put them together, and get my y's, put them together, and take that number and move it over. So this number could be squared, square rooted. The 9 could be negative, so I can't do that. I don't have a square up here or squared up here, so it's not in circle form yet. So what I need to do is I have to complete this square. So next, complete the square within each pair of parentheses. So we do this twice. To do this, examine the first 2 terms of each quadratic expression and determine the constant term to rewrite each expression as a perfect square trinomial. Add those constant terms to both sides of the equation. write the resulting equation. So I'm going to say when I did this process, I need to figure out what numbers will add to this. So I take this number, I divide it by 2, and then I square it. So 4 divided by 2 squared is 2 squared. I added 2 squared to this side, I have to add 2 squared to this side. Then on this one, I take this number, I divide by 2, and I square it. 6 divided by 2 is 3, 3 squared, added to both sides. Then I have a whole bunch of numbers over here that I'll add up to 9. And the reason I did this is because it's a perfect square trinomial. So I can factor it into this form where it's x minus a number, all quantities squared. Oh, look, the squared's up here now, plus y minus 3. That is a perfect square. Squared numbers up here now. So we're going to do some more examples because I agree this is confusing, especially because we haven't been doing a lot of algebra. Okay, so identify the center point and radius of a circle described by the equation in the worked example. So going back to the equation, the center point would be 2 and 3. Don't look at the negative, and the radius would be the square root of 4, which would be 2. So center is going to be 2, 3. Radius is 4. Okay, another question. Consider the general form equation here. How do the coefficients of the squared terms in this equation differ from the equation in the worked example? So the squared terms are this one and this one. Here, they're at 2. Looking at the worked example, it was a 1 and a 1. So how are they different? They have a value, the coefficient is 2. How can you tell this equation represents a circle? So this equation represents a circle because the coefficients of the quadratic term are the same. So the coefficients are the same. Let's go back to Desmos for a second. And if I'd make this a 2, hey, that makes a oval, which is actually called an ellipse. If I make this a 4, now it's really crazy that way. But if I make this a 4, well, now it is the same. But notice the radius isn't 1 anymore. The radius is 0.5. So the radius doesn't really work so well of it being r squared. I'd have to divide each side by 4 to get it by itself, and then of course radius would be changing. So how does the general form of a circle equation change your strategy to rewrite it as a standard form? Well, I'm going to need to divide each side by 2. So I'm going to divide every term by 2. So I would not have 2x squared, I'd have x squared plus y squared minus 1/2 x plus, nope, not 4y, plus 2y plus 1 equals 0. And then going on to the next one, rewrite the equation, we'll just do the whole thing now. So I had x squared plus y squared minus 1/2 x plus 2y plus 1 equals 0. Okay, so I need to take the 1 and move it over here. So, and then I need to combine my like terms. So I'll do some color coding for you guys. So I'm going to have x squared minus 1/2 x plus y squared plus 2y equals -1. Now I need to do the completing the square. So I'm going to look at this number and this number. I'm going to divide it by 2 and square it. So I'm going to have x squared minus 1/2 x. 1/2 over 2 is 1/4. 1/4 squared is going to be 1/16. So that's going to be a plus 1/16 quantity squared plus y squared plus 2y, 2/2 squared, that's just going to be 1, equals, but then I can't forget to add, so I have -1 plus 1, because that's this one, and then I'll draw an arrow, that's this one, and then I got to add the 16 squared. Oh, too big here. Plus 1/16 squared. Now, because I did this, I can then say it is x minus 1/4 squared plus y plus 1 squared, and the 1 and the 1 cancel, so it left me with 1/16 squared. So my radius is 1/16, and my center is 1/4 and -1. Okay, so we got a couple more slides of just lots and lots of repetition, lots of practice. I wrote out the steps that I was talking about. So follow the steps, do the step, and then we'll get the right answer. So first, write the equation in standard form. So that's where I'm making x next to x, y squared plus 4y, and I move this over. Then I'm going to complete the square for each term. So this term is 2/2 squared, that's going to be 1. So it's x minus 2x, or x squared minus 2x plus 1. And I add 1 to both sides. So -4 plus 1 plus y squared plus 4y. I have 4/2 squared, 4/2 is 2. So I'm going to have 2 squared, put the squared there. So I'm going to add 2 squared. The 1 is my term that I use. The x is the term I use. X plus 1. That's how I factor this. That's why I did the perfect square, so I could just take x and the number. Then the next one, y, the number is 2 plus 2 squared equals, this was a -4 plus a 2 squared plus a 1. Those cancel, so I'm left with 1. So I added, okay, recap, completed the square. Add the number from completing the square. That's this on the other side. Factor the perfect square. I'm leaving it as 1 squared and 2 squared because then the y and the 2 go here and the 1 and the x go here. And then I did it. I celebrate. Yeah, good job. Okay, another one. Okay, we'll do it together. We have x squared. Ooh, there's no x term. Okay, that's weird, but we'll keep going. Plus 4y squared minus 24y equals -32. Going before, I would need to have the same number 1 in front. So to get y, I'd have to divide by 4. I'd divide everything by 4, even the x. So that makes this y squared, but this is 1 over 4x squared. So this one cannot be made into a circle. If I graphed it, it would be an elliptical or an oval shape. Okay, we'll try another one. So we're going to write it in standard form. X squared minus 10x, leave a space, plus y squared plus 12y, leave a space, equals negative 51. I'm going to complete the square for each term. So I have 10 over 2 squared. That's going to be plus 20. Nope, I'm not going to do that. I'm going to leave it as 5 squared plus 5 squared. So this is 5. I'm going to leave it as 5 because that's going to be my number for factoring. Then I have 12 over 2. That's going to be 6 squared plus 6 squared. I'm going to add the number from completing the square to both sides. So that's going to be plus 6 squared plus 5 squared. Then I'm going to factor it. And if I've completed the square correctly, it's relatively easy to factor. I'll have x plus or x minus 5 The reason it's minus 5 is because that number is negative squared plus y plus 6. That number's plus, so it's plus 6 squared. And then I'll get my calculator to do some math. I have negative 57 plus 36 plus 25. I get it as 10. So then my center is at 5, negative 6, and my radius is the square root of 10. Okay, so this is now your time to shine. Pause the video, do these steps. When you come back, I'll have all the work done and we'll talk about it. Okay, welcome back. So I tried to color code it for you. Step 1, write it in standard form. I wrote it like this. But it's not really in standard form because there's coefficients in front, so I divide everything by 2. Then I get this equation in green. I'm then going to complete the square for each term. I take 5 over 2, divide by 2 squared. That's going to be 5 over 4. And then I take 4, divide by 2 squared, and I get those numbers in there. Then I add each number to the other side, 2 squared and 5 over 4 squared. I should probably have added parentheses around this to make sure it's the 5 is being squared along with the 4. Then I complete the factor, complete the square, so I get this. I need to finish the problem. I did not simplify this term, so that's going to be negative 5 plus 4 plus quantity 5 over 4 squared and that's going to be 9 over 16. So with all these problems, we want the center. That's going to be 5 over 4 comma negative 2. And my radius will be the square root of 9, which is going to be 3, over the square root of 16, which is going to be 4. So the radius is 3 over 4. My center of 5 over 4 and 2. Okay, so if you want extra credit, you can do the activity on page 714. Do all this stuff. You're going to be doubling and tripling the circumference and the area, so that'll be fun. You'll fill out this table and answer that question. So if you want to do that, extra credit,